This video clip shows a research, entitled, Autonomous Compaction Work of Vibrating Roller Using Field-Installed LIDARs. In Japan, a labor shortage is becoming a problem. It is due to the declining birth rate and aging population. To solve the problems, several research institutes conduct R&D of automation systems for construction machines. The target machine for autonomy in this research is vibrating roller. It is articulate type with front and back refracted. A maximum of 50 meter times 30 meter should be rolled at one time. To automate the vibrating roller without mounting sensors on the machine with vibration, in this research, we decided to use field-installed LIDARs to recognize the machine's location and surrounding obstacles. The proposals of this research are summarized in this figure. Sensors are placed around the environment, as the eyes of the robot. In the actual environment, the range data acquired by the two LIDARs is visualized as shown in the figure. In this figure, the vibrating roller is obtained with such a shape. In this research, we use a template matching method to acquire the position of the vibrating roller in the data. Since the vibrating roller is an articulated type, the angle between the front part and the rear part changes. Therefore, we decided to match the front and the rear, separately. Also, we installed retroreflective tapes on the vibrating roller and used high reflection intensity points. It is for reduction of the amount of calculation, and prevention of false detection. To verify the proposed method, we conducted a position estimation experiment using an actual vibration roller. The left video clip shows an actual scene of vibrating roller, which was controlled by a human operator. The center shows a visualization of the LIDAR data, and the right shows the estimated position of the vibration roller. According to the results, you can see that the proposed system worked correctly. The result of the estimated position is shown in the graph on the left. The position measured by the total station was used as the ground truth. According to the result, the positional accuracy was 0.1 m or less. Generally, a path of vibrating roller is composed of straight lines and forward and backward and curve lines for path transition. Here, we use cloudhoid curves for the curve lines. We conducted an experiment to confirm whole autonomous driving system including path planning. Since the steering control of the actual vibrating roller was not installed yet, this experiment was performed with a vibrating roller of 1/10 size. The left is the result of the actual scene, the center is the visualized LIDAR data, and the right is the result of the estimated position. According to the result, the proposed system worked properly. This is the summary slide. The movie clip shows that the target area was covered by the proposed system based on 1/10 vibrating roller.